Hey Pranjal, I am Aditi and I welcome you on behalf of Bhilai team. Also, hello everyone who has joined right now. We are going to begin our session in just few seconds so that we can wait for a couple of more students to join our session. And today we have very special speaker and instructor with us, Pranjal Bhardwaj, about whom I will let you know in just few minutes. So let's start. First of all, I would like to welcome you all on behalf of Bhilai team. Bhilai is a 24 hours fully online people-focused hackathon, and we are organizing it with the help of our local fellow developers to create awareness and also code collaboration among especially first-year students, so that they can enter into the tech field to get a lot of knowledge. Now, let me tell you all about our special speaker, Pranjal Bhardwaj. He is a community founder and lead at Ethereum India. And also, he is a CEO and co-founder at Collaborins. Also, he is a community lead at Hyperledger. So, in today's session, we will learn all about our basics of blockchain, and he will walk us through all the codes and whole process, how it goes. Also, we will get to know about smart contracts and Ethereum, and we'll have hands-on Solidity. So it's a great opportunity to everyone who is beginning. And I just want to make sure if all you can hear us so that we can begin the session. Okay.
Thank you so much for that wonderful introduction. Yeah, let's just see if anyone can let us know if both of our voices audible and clear. Yeah, you can
Yes.
type something in the chat.
And one more thing, all the links that Pranjal would be sharing with us and all the links related to Bhilai Hacks and this session would be shared in the comment section. And if you guys have any doubt, you can ask in comments. Our team is there to reply you all. Let's not waste any more time. Over to you, Pranjal.
Thank you so much. Hey guys, so in this session today we'll be learning the basics about blockchain. Also, I'll be talking about Ethereum since it's one of those technologies which has been growing rapidly, and everyone should be aware of that. So I'll just go ahead and share my screen for I have a small presentation for you. All right. Okay. Okay. I hope my screen is visible.
Yeah, it's visible.
All right. So yeah, so we'll be talking about blockchain, and I'll be telling the basics of blockchain. Okay, it's not yet visible. Can you just look into it? Um, yeah, it's there. All right. So yeah, so we'll be talking about the basics of blockchain, and after this session, you'll have the basics of basic knowledge about the blockchain concept and how all these different decentralized technologies actually work. Also, you'll be knowing the basics of Ethereum, and you'll be knowing the basics of smart contract development. And since it's not possible for me to cover all these advanced concepts, so I'll keep this beginner friendly, keeping in mind a lot of you are, a lot, it's the first time for many of you to get introduced to such technology. So I'll just try to keep it really basic, and I hope all of you understand the basic concepts. So yeah, so the speakers have already, like the organizers have already introduced me. So I don't think it's important for me to show the slide, but you all can read about me. I've been managing certain communities, and I've been trying to increase the exposure of blockchain and Ethereum Also, like the development over Ethereum blockchain amongst college level students, so that they are able to develop more products based on blockchain, and basically just make different projects on blockchain and deploy them. Yeah, so that is a brief about me. So we'll just dive right into what is blockchain. All right. So just before we start, I'd just like to know from you guys, if you can write in the chat, like how much do you know about blockchain? So you can tell me, like, if you have heard about blockchain, if you have actually if you know the basics and but you have not implemented anything, or if you know a lot about blockchain and you have also implemented some projects, or you have done some or you have written some blogs, or maybe some papers in that in this field. Okay, heard about it. Okay. Yeah, so I think most of the people will be, yeah, never implemented it. Yeah, so most of the people might have heard about it, but they have never implemented it, right? So it's really important for us to get the basics right, so that we can get started with a proper development and making certain projects, right? So yeah, so it's going to be a really beginner friendly session. So let's start with the basics of blockchain now. What is blockchain? So when we talk about blockchain, it is very simple to understand by the word blockchain, because it is what you can understand it by its name. Okay, so it's a chain of blocks which contain certain data. All right, so you can understand this by just reading its name. It can be defined as a chain of blocks that contain certain information, and all these blocks have special unique IDs, which you can consider uh, as a unique fingerprint, which actually uh, which actually creates a timestamp. Now, let's say this information is a document, so there will be a specific timestamp over this document, which will let us know that when it was created, when it was connected with the other blocks, and when it was verified by the people. So it will carry certain information about it. So you can also understand from the diagram, there is a fingerprint like structure on the blocks, which means that every block is unique and every information is unique in a lot of ways. And the chain which is connecting to all these different information, it's creating a blockchain. So so when we talk about blockchain and connecting all these different blocks in chain, we need to have certain traits that so that we can connect them in some way. Otherwise, we won't have a specific way of connecting these different blocks. So for that, we have certain properties of blockchain based on which we are actually able to figure out how do we mine new blocks, and how do we connect them in the chain, and how we can validate them basically. So yeah, you can read about the basic definition. It is very basic. Now moving on to blockchain versus Bitcoin, which is a really big misconception, that many people believe that blockchain is Bitcoin, but it's really not. Blockchain is the concept of decentralization, which is like not storing a specific information in just one place, or you can also consider it as not giving one authority the complete power over something, or in a let's say in a system, you're not giving just one individual all the power to control that system. So when we talk about blockchain, it's a technology of decentralizing things. Is a technology which tells us that we can remove one central identity from all these things. And what Bitcoin is basically Bitcoin is basically a currency system which is based on blockchain. So Bitcoin is a virtual currency that was built over the technology of blockchain. The concepts were taken from blockchain, but Bitcoin is a whole different concept in itself. All the process of how do you validate the transactions, how do you make the transactions, how do you actually mine these new blocks. That is different, and that is defined specifically for each and every currency. And and likewise it's defined for Bitcoin. So yeah, so first we need to understand that there's a clear difference, and we can't really associate. we can't really make both of these things. We can't really say that blockchain is similar to Bitcoin. These are two different things, and Bitcoin is based over the concept of blockchain. All right. So as I told that we need like we have certain properties of each and every block, and there are some components of these blocks which makes them unique. All right. So let's see what are the components. Number one is node. So uh, node is every block, or you can say every individual, or you can say every block in the blockchain. So it is that one individual, or you can say one computer, or you can say one entity in that particular network, which is responsible for transferring information from one place to another. So node is just a user of the computer which is based within the blockchain. Now coming to the transaction. Now, what is transaction? Sorry. Uh, yeah. So what is transaction? Transaction is basically uh, it's a way of creating a chain between two blocks, because if they are doing a transaction, there has to be some sort of connection between them. So let's say there are two nodes, or we can say there are two individuals who want to exchange money. So they'll be building a connection and they'll be transferring each other money. So in this way, they'll be making a transaction, or we can say they'll be making some sort of connection. And this is the basic thing which is required to build a blockchain, because in this way, these two blocks which were completely on their own, which were completely different entities, are now connected in a way, and they are able to interact with each other through these different transactions. So they can send money from. So let's say there are two people, person A or person B, or we can say node A and node B. So node A will be able to send money to node B, and node B will be able to receive money from node A. So this is it's a very basic example of a transaction, which is possible using the blockchain technology, and this is one of the components. Then, when we talk about block is again the data structure which is required inside a node, which is responsible for holding all the information, all the specifications of uh, that particular data point, or you can say which is responsible for storing the information of the transactions made. So as I said, there can be node A and node B. So there will be a part of it which will store all the information about all the transactions that would carried out between node A and node B. How many amount of money was transferred between them, or you can say how many amount of bitcoins were transferred between them. It's the same thing. All right. So yeah. So basically, it's just the way of it's just a data structure which is used to store the information about these different transactions. Now, when we talk about chain is basically a sequence in which these blocks have to be arranged. So we have to arrange them in a way that it's verified, and you know so yeah, in blockchain, we have to arrange them in a way that they are verified by the next block. So this is done by a specific thing that I'll be coming to. So yeah, for understanding it, we can say that the chain is responsible for creating a sequence between all these blocks. All right. Okay. Yeah. So next is the miners. So miners are the specific nodes which are responsible for verifying all these different transactions, and verifying all these processes carried out by the blocks. So miners are there to validate and make those, verify those transactions made. So they'll be responsible for validating it, and they'll be responsible for adding these new blocks to the chain by after verifying them. All right, and yeah, and we have consensus. So consensus is basically a set of rules which is defined. Let's say I'll only add a block to the blockchain uh, if it if it satisfied so and so condition. So this so and so condition will be the set of rules that I'm defining for this blockchain, and this will be and the block will only be added when this particular condition is fulfilled. So in order to achieve consensus, this particular set of rules has to be followed. So when these set of rules and regulations are carried out uh, in a blockchain network to maintain the process of adding new blocks to the blockchain, it is called consensus. And when they are added to the blockchain, it is said that the consensus has been reached. All right. Okay. So yeah, moving on. Yeah. So these are the basic components. Now we can see a simple example. All right. Let's say we have a block one, we have block two, and we have block three. Okay. So as I said, there are some properties of these blocks, or certain data that is stored. So we have something called as hash, which is a unique fingerprint, or you can say unique, uh, a unique number which is assigned to each and every block. And it won't be similar for any other block. It's a unique number which is assigned to just block one. This is going to be a unique code which is assigned to block two. This is going to be a unique code which is assigned to block three. Now, in order to verify that this block is supposed to come before block two, or block two is supposed to come before block three, what we do is basically we have to verify the hash of the previous block. All right. So when we'll be storing these in a blockchain, block two will carry some information that the hash of previous block was this code. Okay. So similarly, when block three will be added, it will carry some information that the hash of block two was this. So in this way, the next block is storing the information about the previous block. So let's say if a hacker was to remove block two, and let's say this block is gone, it's just block one and block three. So the previous hash here will be 8y5c9. But if you look at it, the previous, so these two will be connected and chain, right? So if you look at the previous one, it is 6u9p2. It won't really match. So that time we'll know that some tampering has been done to the network, and some hacker has a particular hacker has maybe removed a block, or he has tampered, or he has changed some information about these blocks, and there is something fishy going on there. So this is a very basic method of understanding how this process of validation, and the storage, how the storage is very very secure on these blockchains. So yeah, so this is the basic concept that the hash of the previous block has to be stored in the next block, and by this way we can verify that these blocks are connected in a particular way, and there's no change that has been done or carried out by an external person, or or a person who's looking forward to a malicious activity on the blockchain. All right. So moving on to the yeah, so as I said, you can just read. There are three main components, which is the data with the information which is carried out on these two different blocks, hash of the particular block, and hash of the previous block. So these are the three information that these blocks actually carry. Now, what is a Genesis block? Genesis block is the first block in the blockchain, and as you can see from the previous example, the previous hash was 00000. There's no hash because it is the first block in this blockchain. So this is called the Genesis block. It only has its own hash, which will be verified by the block two. So sorry, yeah. So we can see that this is like the first block which is added to the blockchain. And yeah, a really fun fact that the first ever block of Bitcoin mine, which was Genesis block, was done by Satoshi Nakamoto in 2009. So we all know that Satoshi Nakamoto is an anonymous entity, or a person who is behind this whole concept of decentralizing money, and who is behind the concept of Bitcoin. And yeah, we say that first ever Genesis block was mined by him, and that is how the Bitcoin blockchain started. So yeah, moving on to the structure of blockchain. So as I said, that in blockchain we are trying to achieve decentralization. So what we are trying to do is we are trying to move away from a central authority, and we are trying to divide things into different parts, so that at any given point we can have a distributed peer-to-peer network. So there will be a lot of peers or a lot of nodes connected in the network which are interconnected, and they can pass on these different informations. All right. So we can see that a P2P network consists of group or devices which collectively store these different files. So you can take the example of torrent. So what happens in a torrent is, let's say we are having a torrent of a movie. So this information about movie will be stored in a decentralized way on different networks, on different people. It will be distributed among different people, And this information will be, if someone wants to download this, the information will be retrieved from all of them, and it will be given to that particular person who's trying to download it. So yeah, so that is the way by which peer-to-peer networks actually work. All right. Then yeah, then moving on to the basic structure of how the decentralized and centralized and distributed network actually works. So in a centralized network, you can clearly see that there is one central authority which is controlling each and every node which is there out in the space, and it is responsible. And if the central authority fails, the whole network will be disrupted, and it will be a huge problem for us. But you can see in the second case, which is decentralized way, there are there are bunch of responsible nodes which further have some branches which contain some computers or some nodes. So this way, the the meaning of blockchain sustains, and we can say that this is a decentralized network. And in a distributed network, each and every computer is connected to each other. So we have distributed data sets, not data sets, databases, and which has been implemented by a lot of big companies and tech giants who store the information in a decentralized way or a distributed way amongst servers of different countries. Okay. Uh, Let me see if there are any questions. And how much time I can learn blockchain and start implementing in my projects. So it won't take much time for you to grab the basic concepts of blockchain and Ethereum. Then you can go on to start projects. I will say if you'll dedicate your time, maybe in a month of, maybe in 1 or 2 months, you'll be able to actually build projects. Given that you have good information and good knowledge about basic web development and how things work, because we'll be dealing with Solidity, which is a programming language which is used to write smart contracts, and which is sort of the logic of our decentralized applications. And to know that language, you need to be really proficient in JavaScript, because it is like really similar to JavaScript. So yeah, what is the main difference between Bitcoin blockchain and Ethereum blockchain? So as I said, that blockchain is the concept behind Bitcoin, and when we talk about Ethereum, I've not spoken about Ethereum yet. So I'll be coming to Ethereum, and I'll let you know how things work in Ethereum. Basically, if I need to give you a small answer, I'll say in that there's just some proof of there's just a difference of mechanisms. There's a proof of work mechanism in Bitcoin, and there's a proof of stake mechanism in your Ethereum. So small difference is that one. But yeah, we'll be talking about both the different blockchain technologies in detail. All right. How do you know when blockchain is required in our project? So you can pretty much apply blockchain to any project which has which might face some problems like storage of data. Let's say we are trying to build a server, or we are trying to build a server. Yeah, we are trying to build a server where we want to store medical data. So medical data is a really sensitive information, and we don't want some hackers to just hack into our servers and get access to those files. So then what we'll try to do is we'll try to make a blockchain network, and we'll be trying to deploy all the information there, so that no one can try to hack and obtain all the information in just one go. It will be really difficult and infeasible for them to hack into our blockchain. So that is one example. Similarly, you can think of various different examples where there's sensitive data involved, or there is some information involved which you want to make sure that is not tampered, or you want to store that information. Let's say if you have insurance documents, you don't want someone to make changes to your insurance documents. So you would try to store them over a blockchain, so that it's harder for the hacker, or if someone wants to attack them, it's hard for them to actually gain access to those documents. So yeah, I'll say majorly it's about the data, and it's about storing and saving the data from people who are trying to get hands on it, and you're just trying to store it in a decentralized way. Okay. So moving on to database versus blockchain. So database is just a single server where we are storing all where we will be storing all our data. While in a blockchain system, will be there will be no central authority who is responsible to store that data. Bits and pieces of those data will be stored on different computers, and the information will be completely decentralized and distributed among all the people who are present there on the network. So yeah, new information will be only added if the people who are already on the network verify and they approve those changes. Then only the new changes will be done to the whole network. Now, why do we need blockchain? Which is basically which will answer your question, like where can we implement our blockchain projects, and what are the spaces and sectors where we can see some applications of blockchain. So we can see that we can reduce. Number one is time reduction. Okay, so thing is we can, so there are so when we try to make a bank to bank transaction, it might take some time in transferring those funds to your bank, or in some cases the transaction fails, and you'll be getting all those funds back in your bank account, and it will be a huge time waste for both you and the person who's trying to receive those funds. So in that case, it will be really useful if we do transactions which is based on blockchain, because all the payments will be done without all the payments will be done without any hassle, and the time which is taken by these transactions is like really less, and you'll be able to transfer money in no time. Number two is reliability. Again, as I said, the blockchain networks are really reliable in comparison to the traditional networks on which the bank sites and the bank servers work. So it will be really reliable that if you're trying to transfer your funds, there is no middle man in the middle attack, or there's no such harmless attack that can be done in the process of transferring money. Okay. Ethereum 2.0, it is based on, yeah. I was referring to the Ethereum 2.0 only, that it will be moved to proof of stake, and Ethereum 1 is using the proof of work. Yeah. Number third point is fraud prevention. As I said, it won't be possible for anyone to hack into the systems, and it won't be possible for anyone to tamper with your bank account or bank information. So there will be a full protection, and which also covers a point of security. Number five is transparency. So when we deposit our money to the banks, we don't really know where this money is going, who the banks are lending this money. Also, there are a lot of things that we can't really question these banks for. But when we try to build a system around blockchain, there is complete transparency when we talk about making payments, or when we talk about storing different digital assets in general. We can say if you're trying to store our NFTs, or if you're trying to make purchases, or if you're trying to buy NFTs from peer to peer in a peer to peer state, then we can see that there is complete transparency, as we have all the information of the previous buyers. If I'm transferring one Bitcoin to some other person, he'll be knowing that who all were owning that same Bitcoin before me, because there'll be a proper ledger which is maintained, that so and so person transferred it to the third person, then third, fourth person transferred it to me. So there's a proper chain, and there's a proper ledger which is maintained for all these different things. Then again, which is blockchain concept is very decentralized and it's very collaborative. So that's why we need blockchain in our in different sectors. We need in finance. We need in a lot of different sectors that we'll be talking about moving ahead. Can we trade NFTs in India legally? So NFTs are trading of general of digital assets, or we can say digital currency in India is not is not banned, and it's not regularized either. So they have not really tried to ban it, or the government has not really tried to stop it. You can do it. It's not illegal. You can do it from, if you have a MetaMask wallet, if you have some ethers in it, you can easily make the transaction happen. There are several marketplaces like Rarible, where you can go and trade these different NFTs. It's not much of an issue right now, but as there is a proper regulatory body which is looking after this, once we have this proper regulatory body that is set up by the government, who is responsible to look after all these different things, like the whole crypto space and the whole NFT space, then we can say that there's a proper regulation of these things. But as of now, they can just restrict it, but they can't really say that. We can't really say that it's illegal or legal to buy. You can totally do that. It's sort of in the gray space. Now, coming to the blockchain use cases. Now, this is the part where you can know the pain points of the current system and the traditional practices that we've been doing for so many years. And based on this, you'll be able to get a lot of different ideas and a lot of different industries you'll be knowing about, and all these different sectors that you'll come across where we can actually implement blockchain, and blockchain can actually revolutionize those industries. So when we talk about markets, there's something called a supply chain network, which is responsible for which is responsible for, let's say, if I'm taking a commodity A from a point A to point B. There's a whole process involved in, as we pass on from one checkpoint to another. There's a whole process which goes on that ensures that the commodity is correct, and it's not tampered. So similarly, in the supply chain network, we can do this process by blockchain by simply creating a simple QR code or something which can be verified by each and every person. And if I'm saying that I'm receiving that commodity myself, I'll be able to know that what all checkpoints or what all different parts of this country that commodity has come from, or what were the different places where it was stored, or it was transported from. So that is the basic of supply chain that we can actually implement in different market sector. Then again, the billing and the monitoring systems that we can apply, and we can use blockchain to basically monitor and track our different products and commodities. Yeah. So coming to the government sector, so there's a huge application of blockchain in voting. There are decentralized applications which can be used for voting, as we know that currently, each and every prime minister accuses the election commission for malpractices in during the voting process. But in a blockchain based system, it won't be possible for them to accuse anyone, because the process will be completely tamper free, and no one will be able to rig the results, and it will be a completely safe network for us to work on. Yeah. Coming to the IoT sector, so again, there are a lot of research and R&D going on in the agriculture space, in making these smart home sensors, which are based on blockchain, or which are based on different mesh networks. So there's a lot of research going on in that space as well. Now, healthcare, as I said, I gave you an example of managing medical records over blockchain, since it's a very sensitive information that we don't want everyone to know. We'll be able to store all those information over blockchain, so that the data is distributed, and it's not hackable. Again, the vaccine tracking thing that I talked, as I said, supply chain. We can, as I said, in supply chain, we can track a particular commodity. Similarly, we can track vaccine. So let's say we are getting vaccine from some other country. So we are trying to import it, then distribute it amongst different states. Then we are trying to distribute it among different centers, then districts, and finally, you're getting the vaccine. So during all this process, you can actually track the vaccine, and if you know where we have received this from, you can track the whole supply chain network. If this was based on blockchain, this information cannot be tampered. So you can't really say that XYZ vaccine is from so and so country, if it doesn't belong there, because you'll be immediately caught, because our information which is stored on blockchain will say the otherwise. So it's really good in that aspect also. And now coming to science and art, again, you can I mean, in the art space, we have been seeing how there's a boom in the space of NFTs. A lot of artists and people are coming up with their digital art, which is being traded on different marketplaces, and people are buying expensive NFTs as for their storage value. People are buying it for to trade it, or even in some cases they can receive loans on these different digital assets. So it's completely revolutionizing the art space as well. Now, the biggest, I'd say, the biggest application of blockchain is in the finance sector, because the decentralized finance, which is DeFi in small, in short, we can say it's the biggest revolution that blockchain has done, because all these transactions that we were doing previously, which was taking a lot of time, or which was taking a lot of commissions in between, it can all be cut with the help of blockchain. If you're doing some transactions, let's say with bitcoins or some other currency, it can be easily cut and reduced. So we don't really have the need of trading through banks or some bank accounts. So that is really helpful for us. Okay, moving on to Bitcoin. Bitcoin was created by Satoshi Nakamoto. As I said, it's an anonymous person, or a group of people who came up with this digital currency system, which is based on blockchain. So I've already spoken about this, and as I said, it's focused on the proof of work model. Now, how do they work? So, anyone can purchase these bitcoins. Now they can exchange these bitcoins among different people. You can trade them. You also have the chance to mine. Sorry, to mine these different bitcoins, that you can do by verifying these and validating these blocks and adding them to the blockchain. So there's a lot of computation power involved in mining, because mining is a difficult process, and a lot of people are interested in mining. So to make the process difficult, um, uh, a large computation power is required. A large graphic intensive power is required, actually, to pull this off. And it's not really possible for everyone to mine bitcoins, because the type of setups and rigs that you require for Bitcoin mining is only feasible for at an institutional level and not an individual level. Yeah. So then transactions, we can make transactions using Bitcoin. We can transfer it to we can use it to basically make our regular day payments. We can use it for transferring between ourselves, between different people. It can be easily done. Yeah, and the concept of hashing, as I said, it's a unique number which is assigned to all these different coins and blocks. Yeah, so that is the basic, like what all can we do, and what are the different components of Bitcoin. Now, again, the Bitcoin mining, we have already gone through that. Yeah, Bitcoin transactions, the information that a Bitcoin has been transferred from one person to the another. It is digitally recorded, and it is written in the distributed ledger. And then this distributed ledger contains information about the previous transaction. Also, the transaction that that will be stored in the blockchain for future references. Let's say I want to verify where this block has been, and what, like, how many bitcoins was transferred from one person to the another. That whole information is stored in those distributed ledgers, which is a really important part of making Bitcoin transactions. Okay. Now coming to the keys and wallets. So basically, uh, transferring the ownership of Bitcoin is a really simple concept, which involves two basic components, which is the public key and a private key. So we can say, like, as I've written, the analogy is the username can be a public key, and you can see the password is a private key. So you don't really share your private key with anyone. You share your public key, and if anyone wants to transfer something to you, they just need to know your public key, and using the public key, which is their address, they can send bitcoins to your account, and using this process, this actually provides us more security. When we say we want to make a transaction, it will provide us more security, and it will make the transaction more secure. Yeah. No, it's not possible to modify the data once it's been stored, because if it will be tampered with, the hash of the block will change. And as I said, the hash of the block is stored in the next block. So that if that doesn't match, then we'll know that that block has been tampered with and the information has been changed. Yeah, yeah, we'll be adding new blocks to the network, but we can't really modify certain blocks to add, just to make changes in the blockchain. That is not possible. Uh, you can keep all type of records. Usually, it's advised to not store private information because these information can be accessed. Uh, I'll give you an example in Ethereum smart contracts. A lot of people, what they do is they store passwords in the private variable, thinking that they won't be able to, the other people won't be able to see their password. But it is possible for them to see the passwords using different attacks that they can perform. By understanding the architecture of the smart contract that they've written, they can actually backtrack and backtrack and reverse engineer the whole hash, and they can actually come up with the password or the variable that you have stored under. So yeah, so you shouldn't really store sensitive information about the particular block. But yeah, you can, in general, you can store all type of records, and it is like it assures a lot of security in that sense. Okay, so yeah, so this is the end of this. Now, just a second. We'll be moving on to the basics of Ethereum, which is slightly different. And yeah, then we'll dive deep in Ethereum. Yeah. If you are looking for some resources to get started with blockchain, you should check out the website of I'd suggest to check out the website of Ethereum, which is ethereum.org. You will find developer documents over there, documentations over there that you can use to start your development journey, and you can also get hands-on resources. Uh, yeah, so basically, you need to first, like, if I were to give you a small roadmap, first you need to be proficient with the basics and what goes in behind the technology. Then you need to actually work on your web development skills, because in order to make projects, in order to understand how the decentralized applications would work, you would only be able to understand them by implementing them. So, in order to implement those decentralized applications, you'll have to learn to code these DApps, which is possible by learning your basic web development. And based on that, we can build a lot of different projects. And yeah, so basically, you should start with your basics of blockchain, then which is the theory, then the understanding of web development, then understanding of smart contracts, which is the smart contract development, and then maybe getting specifics of a particular blockchain. If you're trying to work with Cosmos, you can try to learn the Cosmos SDK using their documentation. If you're trying to work with Matic, you can try to learn how to integrate it with Matic. And if you're trying to learn how to build something on Ethereum, you can just check out Ethereum doc, and you can learn about all these different blockchains and how they work using their documentations. I always say that documentations are the best way of learning anything, because they are compiled by the developers of the particular technology. So Ethereum documentation has been tailor made, and they are given by the people who are working in the consensus or the or the Ethereum Foundation. So the those documentations are really good. I'll also suggest you to check out Solidity by example to understand the basics of smart contract development. I'll just share my screen to show you this Solidity by example. Now, this is a website which contains examples of all these different codes that we have we can try to implement in projects. So when we say I just want to write a simple hello world program, I can just go through this simple Solidity code. I can basically copy paste it if I want. I can understand how it works. But if you're just looking um, to get your hands on these concepts and these logics, you can just go through this website. There's a lot of different programs that is pre-written for you. Let's say I want to understand how the arrays are integrated. Let's say I want to understand how constructors are made. Let's say I want to understand how to make a payment gateway. Yeah, let's say this example, sending ether or transferring and making a call. All these different things are possible. If I'm trying to make an application, the smart contracts are pre-built, and uh, you can just go through them. Let's say I'm make to make one directional payment channel, which is just me transferring money to some other account. We can do that by implementing the unidirectional payment channel. So there are a lot of resources on this website that you can go through. You can also go through these different hacks that by which all these people who are trying to hack into your smart contracts or the backend of the particular application, what is their thinking process, how they're trying to do it. So this is all available on Solidity by example. So this is a really good developer resource that I came across, and I suggest this to everyone. So yeah, so basic Solidity is like really boring if you go through the docs, but since it's based on different implementations, like you have seen in by different applications, like all these different uh, like of all these different examples that they've mentioned. It's really good and beginner friendly for all of us to understand and get the basic idea. Yeah, so that's that's it. Now moving towards the Ethereum basics. I'll just share my screen. I hope my screen is visible to all of you. Hope that's visible. Just a second. All right. Yeah. So there are five different components to Ethereum. First is its cryptocurrency, which is called ETH, or Ether, which is the cryptocurrency that runs on the Ethereum network. So for every transaction which is done, we use Ethos for, let's say, for buying and selling of NFTs. For making a transaction on Ethereum network, we'll be always using the ETH currency, and this is the basic currency which is based on the Ethereum blockchain. Yeah, so it's you can read it. It is used to pay computational resources and transaction fees on Ethereum network. And it's a peer-to-peer currency. So yeah, so let's understand why we need ETH. So Ether can be utilized for building of these different applications, decentralized applications that we're trying to build on this on the Ethereum blockchain. So we can actually write different smart contracts, and we can deploy them to make particular applications on Ethereum network. So in order to run them, we need some fees in the form of Ethereum, in form of Ether that we have to pay to the network. Yeah, so that all that can be done using ETH. Yeah, as we can read, second point, it is used to pay the gas fees, which is required to pay, which is required to facilitate the transactions over Ethereum network. Yeah. So moving on to smart contracts. I've said a lot about smart contracts, so let's understand what smart contract actually means. So smart contract is just a program, or it's just a code that I've written. It's a specific condition that I have described, that when this condition fulfills, a transaction will be made from one person to the another. So I can say, if I have two variables, let's say variable A and variable B, if the sum of both the variables is greater than 10, then execute this particular code. Then execute this transaction. So if it will be going on as, let's say, A is equal to 1, B equal to 3, the condition does not satisfy, the transaction won't go through. But if we are saying A is equal to 10, B is equal to 5, then the sum is greater than 10, then the code will be executed. So basically, we just have to make sure that the logic fulfills, and whenever the logic is actually when the, you can say, the if else condition, or the condition that we have imposed, that is fulfilled, we can say that smart contract will be executed, and the transaction that we have defined, that uh, you know there will be some transfer, or some sending or receiving of ether will be done, that will be executed. Yeah, so anyone can create these smart contracts and deploy them on Ethereum and follow Ethereum blockchain in form of different applications. Yeah, so it can be used for your transferring of money. It can be used for transferring different NFTs. It can be used for anything. We write smart contracts for the transfer of NFTs. We write smart contracts for transfer of different of these cryptocurrencies, which are tokens powered by the Ethereum network. So yeah. Now the features of smart contract. So these smart contracts cannot be altered at any cost. So once they're executed, it is impossible to make changes to it. So yeah, so there is a lot of testing which is done if someone wants to make their project live on Ethereum chain. A lot of different test is done on the test nets, or you can say uh, there are different test nets, ring B test net or local test nets that we use to carry on these transactions. And then once it's executed properly, we can transfer it to the main chain. So this is just because the smart contracts cannot be altered when they're completed, when they're executed. Coming to the number two, any transaction done on top of smart contract is rejected if because these are completely immutable. So this is just the same point, that these smart contracts cannot be changed, and the transactions won't go through. They won't be executed if the condition fails, or if the contract has already been executed. All right. Now, again, carried out among two anonymous parties without the need of a central authority, which is the basic concept of decentralization, that we don't need any central authority to say when to transfer so and so funds to another person. It is based on these smart contracts, which are the logics which we have already defined, and which makes the process really easy. And it actually increases the transparency and trust between different people. So yeah, these are the basic features which makes smart contracts really useful for us, and which can help us uh, in writing smart contracts, and which can help us in writing different logics that we can turn into different applications which can work on Ethereum network. So this was the second component. The third is the virtual machines. Now, virtual machines, or EVM for short, are designed to run these different smart contracts, and they operate as a runtime environment for these smart contracts. So these are responsible for basically converting your EVM code into your in a form that Ethereum will be able to understand it. So it's operated in a sandbox environment, and the developers that code actually have to uh, the developers code will be sort of an agreement of smart contract, which will be done, and which will be uploaded on EVM in order to execute the smart contracts. Now coming to the working, as I said, we can't really just program it in Solidity uh, and just rely on Ethereum to understand it itself. We need to convert this Solidity smart contract into bytecode, which can be understood by EVM. So it is compiled by bytecode. Now, bytecode is that code which is read and which is executable, which is in the executable form, which is required by Ethereum, and EVMs help in that. And again, EVMs are not easy to hack, and it provides security. Now, coming to the proof of stake, which is the basic concept of Ethereum 2.0, we can say that every node has the history of all the transactions, and they carry the current state of smart contracts. Now, if there is a miner, the goal of the miner is to is to both um, now, yeah. So the goal of the miner is to validate the block. All right. So for each of the blocks of these different transactions, miners use their resources, which is graphic intensive mining resources, which is required to obtain that hash, or you can say that that complex password, which is the crux of that new block. And when it is verified, that is added to the blockchain as a new block. Yeah, so miners uh, basically verify these blocks, and they try to crack the hash, and then they add it to the Ethereum chain or any other blockchain. So yeah, okay, yeah. Let's move on to decentralized applications. So we all know that there are a lot of applications that we have in our mobile phones and in our laptop. So these applications are centralized, as in there is some server which is set up in a country on which the logic of this application is running, right? So what we are trying to build using Ethereum or blockchain in general is we're trying to build decentralized applications. So basically, these decentralized applications are D apps which are which don't have a backend code. The backend code is in the form of smart contracts, and which is stored in a distributed way, which is stored in a decentralized way. So it runs on a distributed peer-to-peer network. So these are decentralized applications. So this is just a decentralized form of normal application that we have, and it is said that in future we'll not see any application. We'll just be having different play stores or different stores where we can download these um, where we can download decentralized applications. Now, DAO, which is the Decentralized Autonomous Organizations. Now, these are the digital organization who aims to operate without the need of any hierarchical management. So, we have seen hierarchical management in this case of banks. We have seen it in the case of uh, you know in finance it's bank, in other sectors it's a different central authority, but in case of Ethereum, when we talk about it, Ethereum network, there's something called as decentralized autonomous organization with, there's no authority in it. Still, it's just an organization which is looking after the transactions. They're not really responsible for carrying out these transactions, and yeah, so it's just they just rely over the smart contracts, and it it is available over the Ethereum blockchain basically. So yeah, so this is the basic concept of DAO. So yeah, so this was the basic of Ethereum that we just talked about. So yeah, so the main concept over here is smart contracts, and when we're trying to build different projects and build different applications, all we need is smart contract or the logic of that particular application, which will help us in making a decentralized application, and we'll be able to make different sort of functions, and we'll be able to integrate them. Now, the organizers will share a GitHub link in the chat, which will actually bring you to. Okay, I'll share my screen. Just a second. Yeah, so this is a GitHub repository that I've compiled. It has the presentations that you can go and visit if you want, if you want to just look at them, or if you want to refer something. There's the PowerPoint presentations. Again, I've left the link for Solidity by example website. I've left the link for Solidity documentations, the resources by which you can develop your own smart contracts, and you can learn them. Uh, and there's a very popular online compiler which is called Remix that you can use. I've also provided very basic Solidity codes, which is functions. Yeah, so this is just a very small code that I've written, which tells you how to actually integrate different functions. So you can go through that as well. If you want to learn about smart contract development and developing different developing different projects over Ethereum network, you can look at there's some popular YouTube channels that you can go for, which is your DApp University. You can also refer to Eat the Blocks. They both have great resources if you want to learn. You can just browse the internet for more projects. You will come across a lot of projects which is related to your ERC20 tokens, which is related to Ethereum, and making these different projects over Ethereum basically. So this I hope this presentation was useful for you, and I hope you were able to get the basics for the for how the blockchain works and how the Ethereum blockchain is different from the normal blockchain, and how there's a difference between Bitcoin blockchain and Ethereum. And if you want to just move on to development, you can just refer to this repository. I've left the links. And if you just want to learn anything in specific, and if you want to ask me anything, you can reach out to me over LinkedIn or using my email. So yeah, so feel free to connect with me. Okay, let's see. We have some couple of final questions over here. If India rolls out our own cryptocurrency, can they make it centralized? Yeah, it's possible to make centralized cryptocurrencies. But if someone wants to make their centralized cryptocurrencies, the purpose of cryptocurrency will be defeated because it will be regularized and it will be looked after by a central authority. Because government also wants certain taxes on these transactions, so they can easily they can easily do this, but it's not really something that I'm looking forward to, and I hope something like this doesn't happen, and they make sure that the exchanges which are currently running, they are getting proper they are getting the proper verifications done through government, and they get all the KYC data checked, so that there's no illegal stuff going on there. Yeah, and is decentralized a property of blockchain? Yes, decentralized though is the crux of blockchain. So decentralization, which just means that removing the central authority. So in traditional systems, in banks, and in all these different things, that still has their traditional way of making payments or traditional way of operating. They still have a centralized servers where people control it. So yeah, the basic crux of blockchain is removing that central authority, giving the power to all the people who are present on the network, so that all the decisions can be made by majority, and by carrying out a basic poll. And if 51% of the people agree to certain change, that change will be made to the network. So yeah, so it's a good thing in a way, and yeah, it's the basic crux of blockchain. So if you have any other questions, you can just ask me. Otherwise, I think we can wrap the session up. If you have any other doubts post session, you can just reach out to me over LinkedIn or email. Yeah, we can have a chat about that as well.
I think there are no more doubts. Let's wrap up the session. Thank you so much, Pranjal. That was really an amazing session. I hope it was very helpful to our audience, mostly those who are beginners. And even I got to learn a lot because I did not have any idea about blockchain. So it was amazing and we really appreciate it. And thanks for joining us and being a part of our pre-hackathon events. And also a big thanks to everyone, those who have joined us today and gave their precious time. And you can follow him on LinkedIn as well as on Twitter. He will be there us with the in our Discord community. So I encourage you all to join us our Discord community. We will share the feedback form there as well. You can avail your certificate after filling the form. And if you have not registered in the hackathon, then please do register yourself and subscribe the channel. Okay, Pranjal, you want to say anything?
Just thank you to everyone who came for the session and who want to learn. I will be there in the Discord if you have any doubts regarding blockchain, or if you're trying to make a product on blockchain. You can just ask me if you're having some trouble in integrating something. We can work that out as well. So yeah, feel free to reach out to me. And yeah, thank you so much again to the entire team of Bhilai for actually inviting me for this session. It was really great, and it was a pleasure for interacting with all these people and helping them out with the blockchain journey. Yeah, thanks a lot.
Okay. Thank you, Pranjal. Bye.
Bye.